If a metal ring is heated up, does the hole in the ring get bigger or smaller? I used to always do a classroom demonstration of this. Usually when this question would come up, I would do the demonstration. But here in this video, I haven't set myself up for that demonstration. However, I have looked around and there are quite a few videos of this exact demonstration out there online. So if you do some appropriate search, I'm not sure exactly what search terms you should use, but maybe you can come up with something and let me know if it works. But I'm pretty sure you'll be able to find something for this. But the basic idea is that if you had like a metal ring, so here I'm trying to draw like this, maybe the outside of it, and then there was this kind of cutout section here, or an opening. So maybe it's like a donut, although usually the one that I used, it was like, if you took a cross section of this part, it was kind of rectangular in shape. So even though it could sort of look like a donut, it wasn't exactly a donut, but it has this hole, right? And so we're saying, okay, what happens if we heat this thing up, right? So if I maybe put this like over a flame, and that's what I would actually do, is I would have like a burner, and it would be usually a pretty hot burner. And since I'm not a chemist, I didn't necessarily like to do this. I guess chemists like this stuff, right? But I'm more afraid of fire. Just kidding. But anyways, I would heat this thing up, and as part of the demonstration, I would show, like, I usually had another metal ball that would fit through this hole, but then if you heated that metal ball up first, it wouldn't fit through the hole. And then when I heated up the ring after that, then the ball would fit through again, thereby demonstrating what is actually the correct answer to this, which is that the hole gets bigger. And what's weird about that, though, is our intuition often thinks about like, well, this whole ring is going to expand, right? So if we think about like what that means, we might think like, well, you know, maybe it expands, like the outside part expands to the outside, but our intuition will often like to think, well, maybe the inside part is expanding to the inside, and therefore the hole would get smaller. So maybe I'm going to try to draw a picture of what I just said, but I don't know if it's going to be as good as the first picture in terms of circles. What I was trying to describe is like maybe the inside part would expand like that. This is again what our intuition is kind of thinking, while the outside part expands in the opposite direction. And that's what again leads us to the wrong answer of thinking that that hole therefore would have to shrink. One way of reconciling it is to say, well, the issue is that it turns out this ring also expands kind of along a circular length. So this whole length is kind of expanding. I don't know if I can draw that very well, but it's does this draw it? I'm not sure. But if you imagine that whole ring itself is really getting larger, that is actually going to, you know, there's that effect together with the expansion of the width, but that winds up being a larger effect. And so the net result is that the hole actually gets larger. Another way of thinking about it, though, is to say like, well, what would happen if the hole weren't there? In other words, what if this was like a sheet of metal and I heated it up naturally, right? So if this were just like one big circular sheet of metal here, if I heated that up, it's just going to expand in all directions, and that makes sense. So why should that change if I suddenly decide to cut a hole in the middle? And the answer is it doesn't. That missing part still increases in size when the metal ring is heated up. So that kind of gives you two different ways of thinking about why that might actually make sense. And the answer simply says it gets bigger.